What is the slope of the line tangent to this graph at x equals 2? Let's see. All right, this is going to start getting a little bit tricky, but I want to know the slope of the line tangent to that at x equals 2. So a few problems ago in a different set of notes, we estimated the slope of the line tangent to a curve by just sort of drawing it. Okay, so let's stare at this parabola for a second. Parabola is decreasing, parabola is down at the bottom, parabola is increasing. So we can talk slope and we can say, oh, negative slope, slope of 0, positive slope. We can have those conversations. So at x equals 2, we're right here. And so we would say that the slope is positive, but is the slope this, or is the slope that, or is the slope this? Like we don't know. We don't know what it is. So things are about to get very strange and abstract, but it's going to start coming together. So there is a line right here, and I don't know what the slope is. Actually, I do know, but I don't want to tell you yet. And you probably could draw it and estimate what the slope is, so you can see what I'm drawing. And if I've drawn it correctly, and it's off a little bit, just a wee bit, but if I drew it somewhat correctly, you could say, oh, well, I can estimate that slope, rise over run, fine. But in order to find the slope, I need 2 points, but I'm only dealing with 1. Okay, so here's the dilemma. I want to know the slope at a point. How can you determine the slope at a point when it takes 2 points to determine the slope? Think about it. Well, let's think about it right now. If I want to know the slope at f of 2, or 2 comma f of 2, whatever f of 2 is, which is actually at -4. So I'm really dealing with the slope at 2 comma -4. Oops, shooting pencil at everywhere. There we go. I want to know the slope at that point. Well, that's fantastic. I'll do y2 minus y1 over x2 minus x1. And then I say, well, I only have 1 point. I need 2 points. Oh, well, let's just write it again. And I have -4 minus -4 over 2 minus 2. And we end up with 0 over 0. We have a huge problem, okay? So we can't just say, oh, well, I have this point and I'll use it again. No, you can't. I have to have 2 points, but I want to know the slope at 1 point. All right, so what I could do, and I'm rambling here, in order to find an estimate of the slope, and we've estimated a little bit, we could do 2 comma -4, and we could do 2.1 comma, and then I'll plug 2.1 in, and I'll get an answer out. You can ignore what's on the back side of the paper there. It's kind of bleeding through. I'm going to plug in 2.1, so 1/2 times 2.1 squared minus 2.1 minus 4, and I get this. Yeah, do you want to find the slope between these 2 points? Do you really want to? I mean, you could. It's doable. Let's actually do it right now. So -3.8, 895 minus -4 divided by, and then 2.1 minus 2, which of course are going to be 0.1. And I get that. So that's great. That's 1.05. But I want to know the slope. This is an estimate. Okay, well, then why don't I pick a number that is closer to 2 than 2.1? So why don't we go 2.01? Okay, so let's do this. 2.01, and then whatever the output is for that, so we'll find out what that is. If this looks like it's wasting your time, trust me, I'm going somewhere with this. I don't need that. I'll put that there. Minus 2.01 and then minus 4. And let's find the slope between these 2 points. Okay, that's great. That's fantastic. We got it. Now let's find the slope there. So that last number, which will go up and retrieve that, minus -4 over 2.01 minus 2, which is 0.01. And we have 1.005. Okay, so the previous answer, a few answers ago, was 1.05. Now it's 1.005. Maybe we could get closer, or maybe you're tired of this process. So we could continue, I'm not, but we could and do 2.001, and then you get something. And I want to know the slope at x equals 2. So what I'm really going to do, I'll tell you where this is going. I'm going to find the slope from 2, -4 to 2, and then just a little bit more. And then I don't know what my output would be, so we'll just plug that in, okay? All right, so here's the deal. I could plug in a tiny little number like 0.1 and estimate the slope. I could plug in an even smaller number like 0.01 and just have a smaller increment, or even a smaller number. Why don't I just plug in an h and then squeeze this thing so small and say, well, you know what? H is going to approach 0. Let's do that. All right, here's what's about to happen. A couple notes ago, we had, what was the last note? We had this, the limit of the difference quotient. This is about to happen. I'm not going to write it like that exactly the first time, but basically, I want h. Why is it h? Because that's what textbooks use. I want h to be really small. I'm going to find the slope between 2, comma, f of 2, and we know that to be -4, and then 2 plus h, f of 2 plus h, but we're going to squeeze h and make it very small by taking the limit as h approaches 0. So here goes. F of 2 plus h minus f of 2 over 2 plus h minus 2. We are finding the slope between this point and this point, but we're going to squeeze h to be super duper small, like super duper small. And when we do, what we've done is we've taken this point and some other point that gets closer to it, and this is going to get closer and closer and closer. It's going to get so close that we can smell that slope, and we'll be able to say, you know what, I know exactly what it is. All right. So let's proceed with this process. We have the limit as h approaches 0 of, okay, let's do the easy part first. The denominator is 2 plus h minus 2, that's just h, right? Which is consistent with, check it out, that. Okay, you're going to start seeing similarities with this. And over here we have minus f of 2, which is -4, so minus -4. Now we do have a little mess here to clean up, and we're going to take care of that. I'll switch colors just for fun. And I want to find out what happens if I plug 2 plus h into the original function, and I need to simplify it. And we're going to have a big nasty mess, and it's going to get all cleaned up very quickly. And so let's just quit talking about it and let's do it. I'm going to do it over here on the side. So f of 2 plus h is really equal to, so 2 plus h is going to go here and here. It's going to be 1/2 2 plus h squared minus 2 plus h, and then minus 4. And we will simplify. So 1/2, okay, we'd FOIL that. We'd have 4 plus 4h plus h squared minus 2 minus h minus 4. And you can skip some steps if you want to. 1/2 of that, 1/2 of that, 1/2 of that, minus 6, minus h, and a few more like terms will go together. So we'd have -4 plus h plus 1/2 h squared. Okay, what was I doing in green on the side? What I was doing was saving myself having to write all this over and over. F of 2 plus h led me here. Okay, let's double check our work. Distribute, yeah, we're good there, no mistakes, I think we're good. Okay, so what I got here in green is going to go here. I'll put it in green just to kind of show you where it came from. -4 plus h plus 1/2 h squared. And we can start canceling some things out, and it's going to get pretty clean pretty quickly, actually. At this point, it just starts getting very clean very fast. So the limit as h approaches 0 of, let's see, this -4, let's use red, cancels with this minus -4. And we would have h plus 1/2 h squared over h. We have room to write it again over here, so let's do it. The limit as h approaches 0, I don't always do it this way, but I think it's a good idea. Let's factor an h out, and we'll have 1 plus 1/2 h. And now we can cancel these h's. So let's cancel those as well. We'll cancel this h with this h. Divide them out. And we have the limit as h approaches 0 of everything that's left. So 1 plus 1/2 h. Okay, can we use direct substitution now? Yes, we can. I can plug a 0 right there. I'd have 1 plus 1/2 times 0, and that would give me 1. Okay, where did that take us? I'm glad you asked. We just found the slope of the line tangent to this curve at that point. Let's see. We found the slope of the line right there. Okay, that leads us to the next question, which means we are not going to do this one. This one will not be on your notes because we just did that. And so we are going to find the equation of the line tangent to that. Wait, what? Huh? I need to know, and there's a whole lesson devoted to this later, but I need to know what the equation of this line is. Let's see. I want to know the equation of a line. A line. Let's see. Well, I can do it this way. I can say y equals mx plus b. And I'm going to go about it differently here than I'm going to go about it in the notes when we do encounter it later. But I know the slope is 1. So that's 1. I know an x value. The x value is 2. I know the y value is -4. And the only thing I don't know is the b value. So we'd have -4 equals 2 plus b. So b is equal to -6. So if we were to extend this line, I'm getting excited now. If we were to extend this line even further down, it would cross right here at -6. And so we have an equation of a tangent line. 1x, I'll put the 1 just because the slope is super important in this lesson. 1x minus 6. Okay, what has that told us? What did that tell us? It told us that we can find the slope at a point by taking 2 points, one of which is not too far off from the other one, and we're just going to shrink them really closely together. All right? We did that. We got a slope. We found the equation of a line that's tangent. What's this for? Separate lesson. It'll happen later, but I want to show you something, and I'm going to just put this like right up against the camera. Notice that at this point, the curve and the line look like they kind of overlap at points. Now, they technically only meet at that one point there. However, the values for the line and the values for the curve are so close around the point x equals 2 that we could use the line to make approximations for what the curve actually is, and we wouldn't be too far off. Okay, one more question, and then we will transition to expanding this in a different way. At what x value is the line tangent to f of x horizontal? And I have no way of doing this other than to blurt out an answer, but let's go about it in a logical way. Decreasing, right? Increasing? So if we're talking slope, we'd say, oh, negative slope. Positive slope. When do we transition from negative to positive? Two answers to that question. When we transition from negative to positive, first of all, the transition from negative to positive is 0. And if I have a horizontal line, then my slope is 0. So this question is really saying where, or at what x value, is the slope 0? That's what it's saying. Well, let's find out. Negative, positive, okay? Where did the transition take place? At what x value did the transition take place? There. That's a minimum. That's a minimum. So I drew a line that was tangent to the curve at that point. Well, if I drew a line tangent to the curve at that point, it would be horizontal. And we would have, well, a horizontal tangent line. And a horizontal tangent line has a slope of 0, and that x value, I broke my pencil lead again. You saw it, didn't you? That x value is 1. So, final answer, x equals 1.